we're told the following. We've told that we've got a lift, and I'm presuming that it's an open lift. So here's a building, okay, and we've got a lift on the side of the building, and what we're told is that when we start this whole process, there's the ground, that the distance from the bottom of the ground to the top, to the bottom of the lift, from the ground to the lift, is a height of 28 meters. So this height here is 28 meters. Okay? The next thing that we're told is that the velocity of the lift, the initial velocity is the same as the final velocity. It's constant, and it's 10 meters per second downwards. Hi, how are you doing?
I'm doing well.
Yeah, that's good. I'm sorry we had a bit of technical difficulty getting hold of you, but I'm just sketching your question. Please stop me at any moment that you're not sure if I haven't got the exact detail. Okay, am I doing okay so far?
Yes.
Okay, so we're told this lift is moving is initially at a height of 28 meters above the ground. It's moving downwards at 10 meters per second. And that reminds me something. I need to tell you what the direction is. Let's make the downward direction positive. Okay. Hasha, is that okay?
Yes.
Okay. So what we're told at this particular moment, there's a ball that's sitting at 2 meters above the surface of the lift. So in actually 30 meters above the ground.
Yes.
Okay, so 2 meters above the ground, and it's given an initial velocity upwards of an initial velocity. Let me not confuse you. The initial velocity upwards was going to be 30 meters per second upwards. I'm going to make it minus 30 meters per second.
Okay.
Okay? Because I've said down is positive. Are we all okay with that?
Yes.
Okay. Now, the next thing that we're told is that obviously the lift carries on moving downwards at constant velocity. The ball goes up and it is accelerating downwards at 9,8 meters per second, reaches its maximum height, 0 velocity, carries on accelerating downwards at 9,8, and eventually it is caught 2 meters above the surface of the lift. Am I right?
Yes.
So at some time later, we don't know when, but at some time later, and we're assuming before the lift reaches the ground, sometime later, what's going to happen? The lift is going to be a certain height above the ground, and the ball is going to be a height plus 2 meters above the ground. Okay. And we want to know between this point, between this scenario and this scenario, how much time has taken place. Is that what the question's about?
Yes, that's the question.
Have I sketched it accurately?
Yes.
Okay, very good. Now, Hasha,
Yes.
how are we going to solve this? Any ideas?
We know that the lift is at a constant speed.
Okay, we know the lift's velocity is at constant speed. Good. So we know the lift, the velocity of the lift is going to stay constant. It's going to be 10 meters per second downwards. And we said that's going to be positive.
Yes.
Okay? Right. Any other things that we know?
There is no acceleration.
There's no acceleration on the lift. Agreed?
Yes.
What else do we know to solve the problem? Remember, we're looking for time here.
We know that delta x is equal to v times t.
Okay. Just say that again so that I've got it. I just want to make sure that we're on the same page. Just say it again.
Okay, but we know that the distance is equal to velocity times time.
Okay. It would be better for us to use one of the equations of motion. Let me show you one of the things that we've got here. What we know in common is the final ending. We know the lift and the ball are going to have a common ending. Do you agree with that?
Yes.
So let me set up an equation in terms of the final situation. What I'm going to say is I want the final change in position, delta x, okay, watch here,
Okay.
is equal to the initial velocity times delta t plus half a delta t squared. Okay, are you with that?
Yes.
Now, the change in position that we're looking for, let's have a look and see if we can get an expression for change in position. And the expression that I'm looking at is this change in position. From this point, are you okay? Can you hear me okay, Hasha?
Yes.
Okay, just please be careful of the noise in the background. I'm looking for the change in position between where I initially started, which was over there, or over there, and where I'm going to get to, my final change. So can you agree with me for the moment that the ball started from 30 meters and it's going to end up a distance of, it started 30 meters above the ground and it's going to end up a distance of 28 plus 30 minus 2 minus h. Do you agree?
Yes.
Okay. So the ball goes through a change in velocity, a change in displacement. And we said it was initially at 30, and its final position is going to be, h plus 2. Okay?
Yeah.
That's for the ball. What about for the lift? What's the lift story? Well, it started at 28, and its final position is going to be 28, or the change in position that it's going to experience is 28 minus h, that final h. Are you with that? Okay. So for the lift, we're going to have a change in position. This is going to be the change in position of the ball. And we're going to do the change in position of the lift.
Okay.
Okay. The change in position of the lift, we're going to say is 28 minus h. Now, let's think about this. I've gone to some detail to try and show you that the ball is going to change position and the lift is going to change position. Those positions are not the same. That displacement is not the same. But what do we know is the same during that time that that displacement is taking place?
The time?
The time. Excellent. Well done. So what I'm going to do is I'm going to set up two equations and solve them simultaneously. But you know what? We haven't got time to do that, so we're going to go to a short break, and then after the break, I'll be back and we'll work the solution together. So will you just stay on the line, and we'll go to a short break now.